Howdy, y'all. So we're going to be looking at number 36 from 3-2. And what's interesting about this problem is we didn't call it xyz this time, but we have four different variables. So you might call this wxyz if you chose. And we just label them x1, x2, x3, x4, etc. And notice there are four variables and two equations. So I'm almost guaranteed that we don't have enough information to get a unique solution. But that doesn't mean there's no solution. It's just not only one. At least not just one point. So let's go ahead and rewrite this in terms of a matrix. I'm going to switch my color here. So that first row will be a 1 because there's a single x1. There are no x2s. There are two x3s, negative 4 x4s, and my solution of a 1. There is no x1 in the second row. 1, 1, negative 3, and 2. So what's interesting about the way this is expressed, notice, is I already have a pivot column here. Since the 1 in the top left corner is the first non-zero entry, and you have zeros everywhere else, I already have a pivot column here, since this one is the first non-zero entry in its row, and then the entire column is all zeros besides that. And so what you can say here is we actually already have our reduced row echelon form. So we don't actually have to go much further than this. So therefore, this is already reduced row echelon form. But how can we express this? That's the sort of the bigger thing. These two equations that we have, that's one way of expressing it. But what I might notice here is that if I wanted to do this in a more of a vectory sort of way of expressing things, I might notice that I have two equations, I have four unknowns, and in my reduced row echelon form, these two guys are just kind of hanging out. I don't have any pivot columns in the third or fourth column. And so that tells me my x3 could be an arbitrary parameter. So I'm just going to call it r. And x4 could also be an arbitrary parameter. Call it s. And so I can express all of my other variables in terms of this. So x1, for instance, looking at that first row, could be written as 1. We're going to subtract off of that. Or if you, maybe I should do this for the sake of this example, could become plus 2 times r minus 4 times s is equal to 1. And you could simplify that a little bit to solve it to get just what x1 is. And then x2, likewise, I know if I added r minus 3s is equal to 2. So here's a way of writing my variables in a bit of a parameterized form. And so what I would like to do the more set notation way of writing my solution is first solve these for x1. So x1 is equal to 1 minus 2r plus 4s, and x2 is equal to 2 minus r plus 3s. Okay, so what I'm going to do really for these, when I'm going to write my solution, my whole x vector, I'm going to have a particular solution here, and then I'm going to add to that a vector that has the parameter r involved, and a vector that has a parameter s involved. And so for this one, a particular solution, I just need some value that would work. So for my particular solution, I'm just going to let r and s be 0, which will tell me that x3 and x4 are 0, x1 could be 1, and x2 could be 2. So here's a particular solution. So it's some point that's on my plane here. Now to add to this, I'm going to do r, and think about which of my x's involve an r. Well, looking at this expression for x1, I subtract 2 r's from it. So I'm going to do minus 2. My x2, I subtract a single r, so I'm going to do minus 1. My x3 has just one r, that's the whole of it. And x4 has none of them, so there's a 0. Likewise, for my last sort of vector here that I'm multiplying in, my x1 has 4 s's. x2 has 3. x3 has none, and x4 has 1. So here's a way of writing my solution in a parameterized form. So if I wanted to turn this into something that, as your book might write it, with a little bit more of the set notation, let me put it this way. This is okay, sort of as it's written. But if I wanted to make it more set notation, the way that's pretty standardly done is in the text, as you might think, well, I could write like this. I want the solution set that is all, you might consider vectors x that are in what we call R4, so I have 4 entries, such that, this is solved. So that's sort of the standard way of starting. The only thing you'd have to look for is how many elements does x have. In this case, that solution set can be given as, I'm just sort of rewriting our vectors here. So 1, 2, 0, 0. You can add to that the parameter r with a -2, -1, 1, 0, plus the parameter s, which is 4, 3, 0, 1. And then we have a vertical line, which just means such that both r and s, just so I'm a little bit out of room, are this members of the real numbers, so they're just constants. So this is a set of all numbers that, or vectors that can be written this way, plugging in any combination of r and s.